Hello, welcome back everyone. Hope you can hear me all right. It's a bit noisy in here. It's time now to welcome back Becky, who's going to be hosting our Q&A panel session with 5 of our fantastic ambassadors. So don't forget to put any questions in the Q&A box and we can ask them to the panelists. Becky.
Thanks, Chris. It sounds like it's getting busy in Coventry, so I hope that event is going well. And good afternoon, everyone. Welcome back to our live sessions for Discover Materials this winter, and welcome to the live Q&A session, where we're going to introduce you shortly to our fantastic panel of materials scientists and engineers who are going to be here to answer any questions you have about the subject. Before I introduce myself and the panel, just a quick reminder about the Q&A and chat boxes at the bottom of the screen. Please add any questions in there you've got at any time as we go along, and we'll pick those up as we move our way through the session. So you met me earlier on. My name's Becky Waldram and I work at Swansea University. I have a degree in sports materials engineering and postgraduate degrees in the subject as well. And I currently work as part of a project called Sustain, which focuses on sustainability and decarbonisation in the steel industry to make it fit for a green future. And I also do lots of works with schools, talking to students, talking to the general public about what materials science and engineering is. But this session is all about you, our audience at home and in school. This is your chance to ask us any questions you might have from what subjects we studied in school, what a typical day looks like for us. Just add any questions you've got to that Q&A or the chat box, and we'll try and get through as many as we can during this session. So without further ado, let's get started. I'd love for you to meet our panelists today. I can see a couple have got their cameras on already. If we could get all the cameras on for our panelists, please, that would be great. So to get us started, we're just going to do a quick round of introductions for our audience. So I'm going to start with who's first on my screen, and that's you, Kate. So welcome, Kate Stokes, who works at the University of Birmingham.
Yeah, hi, I'm Kate. I'm based in the chemical engineering department in Birmingham Uni, but I basically do work with materials, so I class myself as a material scientist. I did my undergrad in physics before moving here, and I work with sort of graphene and biological materials to build some cool, hopefully, nanostructures.
Brilliant, thank you, Kate. Next on my screen is Sam Burdett from Skanska. Sorry, over to you, Sam.
Hi everyone, nice to meet you. My name is Sam. I work for Skanska, which is a construction firm. We build buildings and infrastructure. I currently work as a carbon manager in the buildings unit, so trying to make building process more sustainable, and that involves looking at selecting materials that have a low environmental impact. So yeah, nice to meet you all.
Brilliant, thank you, Sam. Next on my screen is Lizzie Mushangwe from University of Oxford. Lizzie.
Hi everyone, I'm Lizzie. I'm a second year PhD student and I'm studying nuclear fusion materials. So if you're interested in nuclear fusion, you can ask me some questions.
Brilliant, thank you. And next I've got Carl Yeo from Loughborough University.
Right. Hello everyone, I'm Carl. I'm from Loughborough University. I'm a second year PhD student as well. So I do polymer-based conductive nanocomposites. Specifically for thermal management of batteries. If you've got any questions that is polymer related, feel free to ask me. Yes.
Brilliant. So it sounds like we've got lots of people with different backgrounds on our panel here today. And it sounds like you're not all from a materials background originally as well. So my first question, everybody has a different route into material science and engineering. Personally, it was a subject I hadn't heard about until I started applying to universities. And then because I didn't get very good A-level grades, I was offered a place through clearing to study material science and engineering purely by accident. And I decided to give it a go. And that's how I got into materials. So I'm interested to hear from our panel, how did you get interested, or how did you learn about what materials science and engineering was? Was there some moment when you were studying in school or a project you worked on that got you interested in what materials science and engineering is? Is there anyone who wants to start on that one?
Yeah, I think I can, if you don't mind.
Yeah, go ahead.
Yeah, because I think my experience is quite similar to yours. So I didn't know the subject very well, but I did chemistry and physics in my high school. So I did a bit of research for this subject. For my subject I did is polymer science and engineering. It is quite related to physics and chemistry. So I thought I might as well give it a try. And it turns out I quite like it. And for a more general topic like the materials, I think this is a most enjoyable part for me, because for different materials, like for example, our laptop, our mobile phones, we know that it's composed of different parts, different materials, but we don't actually know why is it useful in this laptop, why is it useful in the mobile phone, and more specifically, like the batteries, why how the battery is what components have the battery got, and uh, why is it useful, like the electrodes, electrolytes, the separators, and it's all different materials. You know, you probably have heard these terms, but you don't know how useful can it be, and it could be, yeah, extremely useful in different applications. So that's the most enjoyable part for me, to discover, like to discover the essence of different materials in different applications. And essentially these applications are quite related to our daily life. Yeah, and this is a most enjoyable part for me. Thanks.
Yeah, it's really interesting, I think, to see, you don't consider before you know about materials, you don't necessarily think, well, why is that made of a certain material, or why is it made of something else? And it's when you start to realize that everything you look at around you, think, gosh, someone's put a lot of thought into how this has been made and how this material has been chosen.
Yeah, as I started to appreciate like every engineering work, like
Definitely. Has anyone else got a different way that they came across materials or a project? Lizzie?
I studied mechanical engineering for my undergrad, and I always wanted to be in nuclear fusion and nuclear energy, but I didn't want to specialize too early, so I studied mechanical engineering. But at some point in like my second year, I realized that I had nothing to show for my interest in nuclear engineering, but material science kind of allowed me to gain back the nuclear physics aspect that's lost when you study a mechanical engineering degree. It's more mechanics based. But yeah, mechanical material science is very broad, and it kind of opens up your options again. So that's how I got into material science.
Brilliant. That's really interesting. And it's interesting how people seem to go from one subject into another one. Kate, I'm going to kind of come over to you if that's okay, because I think you've come not from mechanical, but like you said, from kind of a more chemistry background. Could you just talk a little bit about that, please?
Yeah, so I did my A levels were in like physics, chemistry, and maths. So I was really interested before I started uni in particle physics. So I was like, oh, I can't wait, I'll go do physics. I did one module in particle physics and I went, no, don't like this, not for me. But I liked physics in general. I was really enjoying the materials-based modules. And then for my second year, I managed to get an internship in the summer working with sort of milling silicon, looking at different what sort of shapes you can make in it with focused ion beam lithography. And then I also got a chance to work with some graphene-based materials and go around sort of a materials lab and have a look. And I found it really, really interesting. And from then on, my perspective completely changed. I was like, right, I'm going into materials. And that's why I ended up choosing this PhD. And I'm a few months away from finishing now, which is absolutely terrifying. But yeah,
terrifying but amazing.
Yeah.
But it's really interesting because a lot of what I talk about quite a lot is you never really know until you try something, whether you're going to enjoy it or not. And it's really important to give yourself the opportunity to try something and not to enjoy it. It's perfectly okay to give something a go and actually decide, okay, this isn't for me, but this has been a really good experience that I now know that isn't for me. And it sounds like that's what happened for you.
Yeah, that's what internships are amazing for, is giving you that sort of 6 to 10 week experience of, okay, this is what it's like working in this field, and then you can kind of go, yeah, or no. And for me, it was definitely yes.
Brilliant. That sounds really good. And Sam, if I can come over to you on that question, how did you get involved in materials engineering?
Sure. Yeah, lots of similarities actually with some of the other panel members. I did maths and physics and chemistry at school and liked those subjects. And I guess the sort of kind of curiosity came before that. I was always asking why and trying to find out why things worked the way they did. And my parents just came up with a stock answer of because that's the way it is. And then I realized if I wanted to find out a bit more, I'd have to go and do it myself. So that kind of curiosity led me down the engineering route. And I ended up doing material science and engineering as an undergrad and wasn't sure that I wanted to work in the field, but then ended up working in the field. And I did a master's in advanced materials for sustainable infrastructure. So that was all focused on the built environment, buildings, construction materials. And I think what sort of blew my mind was just the amount of materials we use. We use a lot of stuff. Every year we use maybe 100 billion tons of materials. And I thought, wow, if I can use my material science knowledge and expertise in buildings and built environment, then that would be, really fulfilling. And that means that I really enjoy what I do as well. So that's sort of how I got into it and where I am now.
It's really interesting having you on the panel as well from a kind of an outside university perspective as well, about how you can use that degree kind of outside the university setting as well. But a lot of people, we're talking about phones and batteries, but people forget, transport, buildings, all the wind turbines, solar panels all have they started in material science and engineering, and there's a lot of sustainability focus kind of on what material scientists and engineers do now. So I guess I'm curious a little bit about what a lot of you do kind of day to day. What does a typical day look like for you? I mean, Sam, yours might look a little bit different, being in an industrial environment. But I might start with you if you don't mind. What kind of things do you get up to on a day-to-day basis in your job?
Sure. So in my role as a carbon manager, I kind of make sure that we complete carbon assessments on our building projects. So there's a standard methodology that you can use to undertake a life cycle assessment. And this is pretty broad, like you don't have to just do it on buildings, you can do it on any material or product type, but there's a standard that's specific for buildings, and we follow that to try and look at all the hotspots of where the main environmental impacts are coming from, and then look at kind of reduction strategies. How can we make this building less environmentally impactful by working with so essentially I work with lots of teams across the business, whether that's the design team or the commercial team, to see what's the feasibility of actually using this low carbon material or this slightly different construction method that's more efficient and uses less material. So it's sort of doing the measuring bit and then looking at strategies to swap out and do different things. So that kind of makes up most of what I do.
So no 2 days are the same then, if you're working with different teams on kind of different building projects, kind of every day throws a new challenge at you.
Definitely. And the sort of general understanding around carbon sustainability is very varied across the business. I mean, there's 3,500 people in the UK who work for my company. So there's huge variety, and that's a real challenge, sort of knowing where the knowledge and understanding is within the business and how to use use different expertise. They know a lot about design, let's say, but they might not know as much about sustainability, and how can we kind of bring those two disciplines together to get the best outcome. So that's a lot of what my role involves.
Brilliant, thank you. Sounds really, really interesting. Any of our other panelists like to talk about what you do in a lab, on a computer, on a day-to-day basis for your research? Yeah, Kate?
Yeah, I'll go. So my days are also very, very varied. I'm coming to near the end of my PhD now, so I end up doing quite a lot of writing. So I'm getting some papers out, which is exciting. But I'm still in the lab, mixing my materials together, growing them, looking at their properties. So I'll do some microscopy. I'll look at their electrical properties. I've also got, because I'm doing a lot of training and stuff at the moment. So before I leave, I'm making sure that everybody else who's taking over my project knows what they're doing. That seems to be what I kind of do day to day.
Sounds interesting. So for anyone who doesn't know, like a paper is where we kind of write up results from all our scientific experiments and let all the other scientists in the research area know what we're doing. A lot of it is very new, kind of cutting edge type science. And it's really exciting when you get a journal paper published. It's like, it's one of the real high points in a researcher's career. And I think, Kate, did I see you managed to get one published recently?
Yeah, I had one that's just come out today actually, which was really, yeah, it was great to wake up this morning and just
Congratulations.
thanks.
That's really good, and really, yeah, so and that will feed really nicely into where you're writing up the research you're doing now for your doctorate as well. So that sounds really awesome. Carl, can I come to you, and you can tell our audience a little bit about what you do day to day?
Yeah, sure. So day to day, basically I do is paper reading and of course lab works. So another point I want to mention is I do day to day, but sometimes we forgot this point is organizing. So day to day we've got lots of data, lots of experimental minutes, and lots of figures, lots of graphs we have to draw. So day to day we have to organize these data, organize these samples, and of course organize my time. Because in my opinion, PhD is quite self-motivated and our time frame is quite flexible. And if I want to take a day off, I can't just take a day off. So if I want to take a week off, of course I can as well. So I think this is quite self-motivated. So I have to organize my time very well. So this is the thing I want to mention, like I do day to day, other than the lab work and paper reading, is organizing all the time, all the samples, all the data, all the experimental minutes. And that's the part I quite enjoy, honestly.
Yeah, it's really
doing
interesting
PhD.
because if you don't kind of label something properly, if you're doing an experiment in the
Yeah.
lab or in school, if you don't
Yeah.
write what
Yeah.
what variable you've changed, or it's how long you've left something, whether
Yeah,
it's what
yeah.
ingredients you put in there, when you
Yeah,
come
yeah.
back to it
We
in a
kind
week
of
or
forgot.
two, you've got no
Yeah,
idea.
yeah.
So
Yeah.
being organized is a really important part.
Yeah.
Lizzie, would you mind talking us through what you get up to on a day-to-day basis, please?
Yeah, I would echo everyone else and say no 2 days are the same, but I kind of work in 2 week blocks. So I have like my thesis that I need to work towards, and I break it down and then work backwards from there. So I'm like, I need to prepare samples, and I'll be in the labs preparing the samples for a few days, and then I'll need to like nano indent them to like get some data and results. And that might be a few more days, and then that kind of spills over into the next week, and then I need to analyze that data, and hopefully the data is good, and then I can show like my supervisors what the work is. So no 2 days the same, and then at the same time you need to like plan ahead and manage your time and schedule. But yeah, I would call and say as well, you can, yeah, it's about time management and really preparing your day. Yeah, that's my time.
I think the good and the bad point of research is that it's not always the same, but the bad point is it doesn't always work as you expect. And so
Yeah.
like you were saying, you do have to be a bit flexible if something doesn't go to plan. Maybe you dropped your samples on the floor. You need another day to prepare samples. We've all been there, I think.
Maybe a machine breaks or something, and that like pushes you back a few days. But yeah.
Yeah, or if you need to contact an expert in a certain technique, they're not always available. So yeah, it's really interesting what you were saying there. But it sounds like it's a good mix of different things. You don't get bored doing the same thing all the time. You get to try out new techniques, meet new people, and try things that maybe you haven't tried before.
Exactly. Yeah.
Brilliant. That sounds really, really interesting. I'm going to talk about materials a bit more in generally, and we've spoken a little bit about sustainability, about how we're using materials in buildings, in batteries, in different areas. What do you think one of the biggest challenges facing material scientists is at the moment? I know this is quite a big question, and it might depend on the area you're working in, but what sort of challenges do you think are important now, or are going to be really important for some of the people watching when they grow up, the challenges that they could be involved in material science and engineering? Anyone want to take that one?
I think one is quite high level, but I don't think people understand how relevant material science is to their day-to-day life. It like expands from cars and the aerospace and the automotive and just biomedical. It just touches everything. So everything that's been designed and every technology that's made needs a material scientist to validate it. So people aren't really aware how important it is. So maybe that one.
I think that's a really good point. I think if you're sat at school or at home right now, you're sat on a chair. that's a material that someone has considered, you know, is that strong enough for its job? You might be watching on a laptop, on a mobile phone or a tablet right now. We've heard from a few different people today about the number of different complicated materials that go into creating these sort of devices. So I think you're absolutely right. Everywhere you look, basically, if an object's been made by a human, it's probably had some material science involvement in its design, in its testing, and how it's been built as well. Kate, did you have a point to make on that one too?
Yeah, I mean, in my area especially, I know that, I mean, graphene is like an amazing material. Its electrical conductivity, especially, it could be so conductive, it'd be useful for so many different things. But one of the problems is scaling it up, because the way that they found it was just literally like sticky tape on some carbon, and whoop, there we go, graphene. We can't have loads of people going around going oop, 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 to make graphene all the time. And there are other ways of making it, but it introduces like defects, and that reduces its conductivity. So scaling up materials can be a real challenge.
It's really interesting that you're talking about how graphene was discovered there as well. I think that's one of my favorite stories. It was sellotape on a piece of carbon, and that is how a lot of amazing scientific discoveries are made, to be perfectly honest, is by accident. And that is one of my favorite examples, I think, of just sellotape in a piece of carbon. So thank you for bringing that one up. But as you said, doing that on a large scale, we don't just want a massive sheet of sticky tape on some carbon to create that material, because the problem we've got is we want materials to be made in the same way, so they have the same properties, so they behave in a similar way, so that we know what to expect when we're using them to make products that people will use every day. Sam, I wonder if I can come to you and maybe talk about some of the sustainability issues in materials at the moment, especially in the construction industry.
Sure. Yeah, I mean, I think on Kate's point, definitely echo that in the construction industry, to get a new product from concept and in the lab to being used by, you know, hundreds of construction projects, that could be 10 plus years or maybe more. And it's like, okay, we need to reduce the impact of materials today, and there's that lag between actually getting new materials that have less environmental impacts available on construction sites. So that's definitely a big challenge, because the demand for these more sustainable materials is only going to grow from here on out. You know, that's how I've sort of moved out of the materials research side of things, but I'm still tapped into it, you know, as many places as possible to sort of work with, you know, industry and academia to accelerate that kind of technology adoption. So that's a really big one. And another one is kind of comes back to just understanding the impacts of how you make a material. So this process life cycle assessment, where you look at all the inputs. So imagine like a cake, you're making a cake and you've got all the different ingredients that you're putting into the cake. 100 grams of flour, 1 egg, all of this. You list a whole list of all the inputs, and then the energy that you need to turn on the oven. That goes in, and then out you get your cake at the end, and then you can figure out what the environmental impacts of all the materials and all the energy that you use to make the product. So that's quite an involved process that requires quite a lot of skill and knowledge, which there just needs to be more of those assessments done on more products, so people can make that informed decision when they're selecting between two different products. They can say, okay, I'm going to choose this one because it's got a lower water usage or it's got a lower carbon footprint. So that kind of skills and data is a really big part of the challenges that we're facing.
I love linking it to food and making a cake. We were talking about chocolate in the session before this. I think cake is also a very great example of kind of chemistry of materials and how they're made up as well. If you change how much raising agent, how much bicarb is in a cake, you get a totally different cake. So thinking about it, of where all those ingredients have come from as well is another way of using that. And if you think about it on a building scale, you've got so many more components than you have in a cake, so that adds to make it more complicated for you and kind of how you store that data. So there's going to be a lot more people in data science potentially that we need in material science, and in the world in general going forward, I think, from what you've said there.
Definitely. A quick anecdote. So the building part of our business is 300 people roughly. About 3 years ago, there was pretty much no one in the data team. Now we've got about 30 people, all different roles in terms of using digital tools on construction sites, cameras on their helmets, looking around, taking stock of what's happening on construction sites, but then also doing all the data analysis on the back end in terms of all the data we collect. So yeah, huge growth in roles, yeah, it's a really exciting area.
Yeah, definitely. And one we seem to need more people with materials knowledge in, as well as having those good computer skills. It's kind of tying those two areas together, where I think especially in our department, we're struggling at the moment to find people with both sets of skills. So going to be a really, really important one in the future. And Carl, what about you? What do you think the biggest challenges facing material scientists are at the moment?
Yeah, this is actually quite interesting because I discussed this question with my colleague this morning. And what in my mind, I was thinking about the gap of technical readiness between industry and academia. But my colleague, she said some different thing from another perspective, which I found is quite interesting, because she said not a lot of new people are joining this subject, choosing this subject, because material science and engineering is not very popular when students are choosing in their A level. So yeah, I think this is a big challenge as well for me, like a materials scientist. So because not a lot of new people are joining, and not everyone is familiar with this subject. But if you look at different courses like automotive engineering or aero engineering, they've actually got this course, like a materials course, in their course as well. So I think materials is quite a broad course, and this course is going to be quite useful for building up your foundation. Like if you choose this course, the knowledge and the skill set is going to be quite useful for basically every engineering area. So yeah, I think that's from my colleague, but I think yeah, it's a fair point. Not a lot of new people are joining this.
Yeah, you're right. It's a really big challenge, actually, is people not knowing about it. And I think it comes from in school. Material science wasn't a subject that you studied. You had physics, chemistry, biology, maths, product design, and all of them had little elements. And there's probably more as well, but had little elements of material science in. But they were never really joined up. So in physics, you might do I don't know if you all did this, the classic taking a chunk out of a plastic bag and adding masses to it until it's stretched. And then obviously in chemistry, you'd learn about like making polymers and plastics and different materials. Product design, you'd be picking materials to make an item out of. But for me, it wasn't until someone talked to me, it was one of my teachers actually in A-level, about what manufacturing technologies were, that I really became interested in kind of, hang on, all these materials need to be treated differently and processed differently. And so it is almost having teachers, parents, friends who know about what this subject is that can help people tie the different areas together and make them realize it is a subject at school. And it's really great to have you all here today to talk about your experiences in material science and engineering. So hopefully we can inspire some of the people watching to want to get involved as they start to study GCSEs and A-levels in the future. So we've got time for a couple more questions. Let me just have a quick look if we've had any in. Okay, so if we're talking about people in schools, is there any advice you would go back and give your younger self about what subjects to study, or things you wished you'd know about when you were younger? Or was there like a teacher in your school who really encouraged you to study science and engineering? What kind of would you recommend, maybe books or websites potentially, to young people who don't really know what they want to do for a job right now, or what you would tell your younger self if you were to go back? I'll give you a minute, Lizzie.
I would say try to find the intersection of like subjects. So if you like physics, as you study material science, you realize the subjects kind of bleed into each other. So you can find interesting, if you're interested in games development or something, try to find like the intersection of games development and material science, and then it'll be more tailored to you. And for a practical skill, just learn Python and a programming language, because that's very useful in the future, and really get really good at it. So you'll be absolutely amazing by the time you start university.
Yeah, I think that's a piece of advice I needed. I've kind of steered clear of all programming languages, but I sometimes really wish it's something I'd taken up when I was younger, just because, you know, I like computers, that sort of thing. I kind of wish I had. And like you said, tying things in with your hobbies as well is a really good one, because it means that you'll end up doing something that you enjoy as well. If it's a hobby and a subject at school that you can tie together, then you are much more likely to enjoy it and find a career that you really like as you get older. Anyone else? Kate, I think I can see you. Do you have one for us?
Yeah, I was just trying to have a think. I think honestly, what made a difference, teachers do make a massive difference. So I had a teacher, so in year 9, I hated physics, which is unbelievable since I've now done a degree in it. But in year 10, I got an amazing science teacher, and he just made physics fun. And that's when I suddenly realized how interesting it all was. And I think taking advantage of any opportunity you can. So I've been to like we had residentials, and you could sign up, you know, just have a look what's around, have a Google, see if there's any. I went to one called Villiers Park, and they do like residentials there where you can learn about different subjects, hear from different people and different experts. And having that kind of gives you a better idea of what you want to do. It gives you different perspectives. So for instance, if you have a teacher that you just don't gel with, which happens, if you then hear about it from a different perspective, then you might be like, actually, I am really interested in this subject. So yeah, any opportunities you have, take them.
And it's never too late to change your mind either, is it? I mean, okay, so you might have picked GCSEs, A-levels, but there are always opportunities after that to retrain, to learn new information if you find that something really interests you later on.
Yeah, I was just gonna say, I mean, I stopped at GCSE biology. I didn't do A-level. I didn't do a degree in it. I'm now combining graphene with biological materials. And my first day here, I was in a bio lab, and I'd never even used a pipette before. So it was a big big transition. But yeah, it is never too late.
I had a similar with chemistry. I really didn't like it at GCSE. I did as much as I could, couldn't wait to drop it at A-level. And then I became an electrochemist at university, and I thought, how did this happen? I don't remember doing chemistry. So I had a very steep learning curve where I had to suddenly learn a lot of chemistry in a very short amount of time. But once I knew what it could be used for, I was so much more interested in learning about it, and what it meant for like actual work. Doing it in an experiment makes such a difference as well, rather than just reading about it in a textbook. Carl, have you got any advice that you would give your younger self about studying and careers?
Yeah, so my thought is probably do some more research, but in a general way. Because yeah, when I was young, I quite liked asking why is it happening? What's the working principle of different things? But after a while, I kind of forgot this question and I just dropped it. But probably I think I can just for my younger self, I can just do some research or either just Google it and get some general knowledge about this thing I'm asking and this for myself right now, I think this general knowledge could be quite inspiring, honestly. Like at that time, if I did some general research and I've got like a rough idea what's this thing look like, and in the future, at least I know something about this, and yeah, I can start off from that point. Yeah, that's the advice I would like to give my younger self.
I
Don't
love
be
that. Keep
afraid
asking
to
questions, I think. Yeah.
yeah, and just do some research, even it's quite general. Yeah.
Brilliant, thank you. And Sam, I'm going to come to you last. Is there anything you'd like to add from what our other panelists have said?
I think they've all summed up really well, and yeah, very, very similar thoughts to all of them. I think for me, you know, obviously my job is revolving around building buildings, but I don't actually build the buildings, and a lot of what I do is data related. So yeah, data analysis and understanding what you can do with data and how you might want to collect it. So I talk a lot with our site teams who are actually collecting the information from sites and how they do that, and the processes that they use, so that I can make the help make the decisions on the data. I think that's a really big one. And yeah, the other bit is just sort of in finding something that you enjoy. I think that's already been raised, but if you can find an intersection of your interests and something you really enjoy and passionate about, it won't feel like work, basically.
Yeah, absolutely. I think that's a really important one. Is someone said you never work a day in your life if you do something you enjoy. I think that is really, really important. And a really interesting point you brought up there. You work in the building industry, but you don't build the buildings. There's a lot of jobs within different industries that you don't necessarily. So to work in the NHS, you don't have to be a doctor or a nurse. There are lots of other jobs in that area. I work quite closely with the steel industry, and it's not all about people working in the blast furnaces and the hot mills, those sort of things. There are lots of other jobs in lots of different industries. So you don't have to be limited by, oh, well, I don't want to work on a building. To work for a construction company, you don't have to work on a building. And it's really important to know that there are so many different opportunities within different universities and businesses out there, and where you could go in the future. Okay, so I think we're going to have one more question for our panel, and I'm going to ask you what your favourite material is. So while you have a think about that one, I'm quickly going to tell you about mine. I've just mentioned the steel industry, and steel is absolutely my favourite material. You can use it for absolutely anything. You can recycle it. It's totally recyclable. We can use so much more of it. You know, when you have a dishwasher or a washing machine that stops working, you can recycle it. You can get that same steel back in a different way. And I think it's a wonderful material it literally makes everything around us. Everything's either made from or made using steel. And I think that's really incredible for a material. So I'm going to come around backwards. Sam, I'm going to let you go first this time. Could you tell our audience about your favourite material, please?
Okay, another one of the big materials that we use, concrete, I think is definitely up there for me. Every building will have, well, not every building, but the majority of buildings use it. After water, it's the most used material in the world. We get through an incredible amount of concrete and cement, which is kind of the binding agent within concrete. It sticks all the sand and aggregates together. And it's got so many amazing properties, strength, its durability, can last for hundreds of years, fire resistant. It's fairly cheap, to be honest, and actually its environmental impact is reasonably low when you compare it for the same amount of other materials. It's just that we use a huge amount of it. I think what's really exciting for me is that there are so many amazing, clever, intelligent people working on reducing the carbon emissions and environmental impact associated with concrete production that it poses a big issue at the moment, but I've got lots of confidence that we're going to solve, you know, a lot of our issues surrounding concrete over the next 10 to 15 years. So definitely going to be watching that space really closely.
Yeah, brilliant choice. Concrete and steel go really well together and are often used together as well. So they're two big ones to start. Lizzie, could I come to you next, please?
Yeah, sure. Mine is a Repco, and it's a superconducting magnet, and it's really good at holding plasmas. But what's really cool about it is like if we continue to develop it and increase the strength of it, we can like make maglev trains, and I like the idea of having like magnetically levitating trains and cool things like that. But it can also be used for like medical tech as well, so that's cool. So it's very transferable.
So for our audience, you haven't come across magnetic levitation, it's basically like where something looks like it's floating above something out. Is that right, Lizzie? And it basically, it's much more efficient because there's no friction. If you heard earlier about Santa's sleigh, we were talking about the friction of Santa's sleigh on the ground. It's very efficient as well, isn't it?
That's quite like it.
Yeah, brilliant. I love that material. That would be a game changer if we managed to develop that on a very large scale. Carl, can I come to you next, please?
Yeah, sure. So I think my favorite material is probably the same as Kate's. It's gonna be graphene because I don't know. It's just amazing because the chemical structure is quite simple. It's just carbon connected together, but it's got so many excellent properties, and people are still publishing new paper about its new properties. And as Kate mentioned, they are just playing with the sticky tape and the pencil, and boom, they've got the graphene, and they've won the Nobel Prize. I just got amazed about how amazing the science is. And yeah, I think that's how amazing science is, and that means there's still a lot more you can get from our daily life, right? Just from the sticky tape and the pencil, you can get a Nobel Prize, right? Yeah, that's my favorite material.
Yeah, absolutely. And I don't know if Kate is sat there thinking, I'm going to come up with a different one, or you're going to stick with graphene, Kate. So over to you.
Well, yes, graphene will always be one of my favorites. But I think my other favorite, I guess, is one I also work with. So I had my mind blown when I first started here that biological components can be integrated into materials. Because we're taught about them so separately, I always took them as completely separate. I didn't realize that you could integrate them. So I work with a material called the M13 bacteriophage, and it's like a virus, which I automatically went, oh no, but it doesn't infect humans, and it replicates inside E. coli. So then you can like genetically and chemically engineer it, so you can change all of its properties. So you can change it so it binds to metals, so it binds to cancer cells, so it binds to fluorescent materials. So then if you could do that, and if you bind it to fluorescent materials and cancer cells, boom, you've got fluorescent imaging of cancer cells. And it's just got so much versatility. I think it could be amazing.
That's a really cool. So we've had building material, we've had steel, concrete, we've got these amazing superconductors, we've got biological agents, we've got graphene. I love the variety of different materials we got there. And I think, well, even looking at the periodic table, there are so many different elements out there. And we can join them together to make these fantastic materials. So I think, unless any of our panelists have got anything else that they would like to mention to our audience, I think we're going to wrap this up there, if that's okay. So thank you very much, all of you, for joining us today and sharing your experiences with our audience. I really hope they've got an idea of what an incredible topic material science and engineering is now, and how they could potentially be involved in it in the future. So I think I'm going to hand back to Chris now, just to wrap up the day. Thank you very much again, everyone, and over to Chris.
Thanks very much, Becky, and thanks to all the fantastic panelists.